Hi, in this video we'll look at the sine rule. So, bit of background, for non-right angle trigonometry, there are basically three rules you need to know for GCSEs. All of these you have to remember the formula, and they all use the same layout for a triangle, where in each case the angle is always opposite the length of the same letter. So this A is opposite this A, this B is opposite this B, and so on and so forth. The three rules are the sine rule, the cosine rule, and a triangle, and here we're going to focus on the sine rule. So, use this rule when you have a side and an opposite angle. So both these are cases where we'll be using the sine rule, because you can see we have this pair of side and opposite angle. Typically, you'll then be given another angle. So let's say this is 40 degrees, and has to work out a length. Or you'll be given another side length, say this is 24 centimeters, and be asked to work out an angle. But the key thing is, you will always have a pair of opposite side and angle where you know what both those numbers are. In other words, neither of those two numbers in blue are an x. Okay, let's see how we can use it. So the sine rule comes in two forms. So similar to the cosine rule, we want to use the form on top when you work out missing lengths, and you want to use this form when you're working out missing angles. So let's look at this question. Here I am trying to find a missing length, that's what my x is. So I'm going to use this top form here. First thing I'm going to do is label my triangle. So how you label it doesn't really matter, just keep in mind if this is angle A, then the opposite length must be side A. So AA and BB. I'm then going to fill in what I know. So A over sine A is going to equal B over sine B. So we have this formula here, and we want to get x by itself. So looking on my right hand side, I currently have x being divided by sine 55, and the opposite of dividing by sine 55 is timesing by it. So if I times both sides by sine 55, the effect it's going to have is it's going to move it up here with the 11. So now I've got 11 times sine 55 over sine 62 equals x. Okay, so make sure you're okay with that, because that comes up a lot in these type of questions, that trick moving this from basically moving it across from one diagonal to the other. Now we've got in this form, all we need to do is just plug into my calculator. So fraction 11 times sine 55 all over sine 62. That will give us x, which is 10.2. So if mentioned, if you want to, you can look at your triangle and see, does 10.2 look fairly reasonable? And here it does. Like, it's similar to 11, so 10.2 is a reasonable answer. If one else that's like either really small or really big, you'd be fairly confident it's going to be wrong. Okay, so we've got another example. So in this case, we can see we are trying to work out a missing angle. So the angle called x, keep in mind occasion angle is labelled as theta, but that basically just means an x. So for this case, I am going to use this form of the sine rule. Again, I'm going to label things. So what you label doesn't really matter, as long as you make sure that each angle and length are opposite one another. So AA, BB. Then I'm going to plug everything into my formula. So sine x over 9 equals sine 100 over 20. Again, we have a divide by 9 here. And we should know the opposite divided by 9 is timesing by 9. The effect that has is that's going to bring it up to the top of the other fraction. Now I've got sine of x, how I want to get x by itself, and the opposite of sine is going to be sine to the minus 1. So it's going to be sine to the minus 1 of this term here. Then again, we've done all the hard work, that's all we need to do. So again, the hard work here, like with the cosine rule, is just remembering the formula. Then we just plug it into my calculator. So sine to the minus 1, and then put in that fraction. So 9 times sine 100, all over 20. Okay, and there we go. That's our missing angle. So that angle is 26.3 degrees. And just for, I'd say, have a quick look at it and see, does that look reasonable? Does X here look like 26.3 degrees? And yeah, it kind of does. It doesn't be exact, but like, it's obviously not going to be really tiny or also like an obtuse angle above 90. Okay, that's the basic idea of the sine rule. Again, two formulas, one for finding lengths, one for finding angles, and apply them both. However, here we've got a few special cases. Okay, so it turns out that values of sines comes in pairs. You kind of learn more why at A-level maths, but if I look at sine 60 and sine 120, they're exactly the same. Same with sine 10 and sine 170, same with sine 50 and sine 130, and sine 16 and sine of 174. These are all the same. And there's a pattern to these. If we look each of those pairs of numbers that gave me the same answer, they all added to 180. So here 60 plus 120 gives you 180, and the same is true for the other three pairs. That means if we know, for example, that sine of x equals this number here, we don't know what missing angle that is. We know the missing angle is either going to be 60 degrees or 120 degrees. But there's no way we can know for sure unless we have more information. So what you will see in some questions I'm going to look at now is it will tell you the angle is obtuse. So here, given this angle is obtuse, we need to find its value. And now we're going to use that trick. Okay, so I hope that makes sense. So let's go through it. So the start's not going to change. We're going to use the exact same formula. We are finding a missing angle. That means we want our sines on the top. Next, we label our triangle. And we're going to plug things in. So sin x over 16 equals sin of 30 over 11. Just as before, we are going to times by 16, so that joins the top of the fraction. And in fact, just as before again, I'm going to undo the sign by doing sine to the minus 1. So if I do sine to the minus 1 of this, that will give me what x is. Okay, next we can type that into my calculator. So copy this into my calculator. And that gives me x being 46.7 to three significant figures. That would be it, except for the fact we are told that angle x is obtuse. And what we have found there is an acute angle. So just as we saw before, we know its pair will be 180 minus that. So for example, if I got my angle being 60, I know the other angle was 180 minus 60. So in this case, we're told angle x obtuse, you work it out as normal, and then for your final step, you'll have to do 180 take away it. Okay, again, to explain more to your A-level maths, so I'm not going to go through any more here, but that is the basic rule. So again, keyword to look out for, check whether or not you're told an angle is obtuse or not. If it is, work everything out as normal, and then right at the end, do 180, take away your answer. Okay, here we have the exact same layout. So I'm just going to through this one more example. First things first, a slight change. We have an isosceles triangle, which means if this is 6, so is this. So in this example, we're not actually using the sine rule at all. We're given the area of a triangle, which means we're on the area of the triangle formula. However, we have the same problem, that this angle x is obtuse. So let's go through it the exact same way we went through the sine rule, but instead we're using this formula instead. So label my triangle, that's angle C, and that's A and B. Fill in what we know, the area is 9 root 3. Again, the fact that this is 9 root 3 doesn't change anything, it's just a more exact form than giving it as some sort of decimal. That is going to equal a half times 6 times 6 times sine of x. Again, we want to get sine of x by itself. So the opposite of timesing by all this stuff is dividing by this stuff. And again, we now want x by itself. So we need to do sine to the minus 1 of what we've got over here. Then we reach for our calculator and we can type that straight in. Okay, so I've typed it in, press equals, and that gives me x equals 60 degrees. Again, we look at the question and we were told that this angle is obtuse. So we've got an acute angle. Whenever this happens, all we need to do is do 180, take away the angle we found. And that'll give you 120. So therefore that missing angle was 120 degrees. Okay, that's all we have today on the sine rule. So again, key things are those two formulas, and read the questions carefully to tell you whether or not an angle is obtuse or acute. As a rule of thumb, if it doesn't say either way, it will always be an acute angle. It'll only tell you for sure if it's an obtuse angle. So if they say nothing, you can assume it's acute. Okay, thanks for listening.